Week 2, Lesson 8. I will let you read and look at the pictures. Our goal today is to figure out if you have a plane given, right, which is what you see right here. You've been given a plane. We're trying to figure out which of these three lines intersects it, which one is actually on the plane, and which one is parallel. All right, so what we're going to do is we'll just go ahead and start with line 1. We're going to write line 1 in parametric form. Okay, now just a reminder, you did this before. Just keep in mind that each of these little like pieces equals k. So if you just kind of k, or I'm going to use lambda, but x, for example, x is equal to 2 lambda minus 1. That's a lambda. And y is equal to negative lambda plus 3. And z is equal to 3 lambda minus 2. Okay, so now that I have them in parametric form, I can just plug them in to the equation of the plane and see what happens. Okay, and there's 3 different things that could happen, which you're going to see all 3 of these because of the 3 different lines. So for this one, if I plug in x, y, and z, I get 2 times 2 lambda minus 1 plus my y value minus the z value. Again, parentheses are important. Don't forget to distribute. All right, so distributing 4 lambda minus 2 minus lambda plus 3 minus 3 lambda plus 2 equals 3. And if I simplify all of that, I end up getting something like 3 equals 3, which means that line 1 is on the plane. Okay, if you end up with something equal to itself, that means it's on the plane. Okay, I'm going to switch colors. Let's do line 2. Okay, so for line 2, again, starting with parametric form. Okay, x is going to equal lambda plus 2. Y is going to equal 2 lambda. And z is 5 lambda minus 1. And then again, I'm going to plug them in. So 2 times lambda plus 2 plus 2 lambda for y minus 5 lambda minus 1 equals 3. So 2 lambda plus 4 plus 2 lambda minus 5 lambda plus 5. No, not plus 5. Plus 1 equals 3. And simplifying this, I end up with negative lambda equals negative 2, or lambda equals 2. Okay, this means that it intersects at a point. Okay, intersects at a point. Now, if it intersects, I want to know what point it intersects at. So I'm going to take this lambda equals 2, and I'm going to plug them in so that I have an x, a y, and a z. I'm going to let you do that, but you should end up with 4, 4, 9 being the intersection point. All right, and then let's do line 3. I'll switch back to blue because the only other color that I have is green, and I think it's a little hard to see. So for line 3, in parametric form, I have x equaling negative lambda, y equaling 4 lambda minus 5, and z equaling 2 lambda minus 3. And again, I'm just plugging in, so I end up with 2 times negative lambda plus 4 lambda minus 5 minus 2 lambda, that's a lambda, minus 3 equals 3. Simplifying, and again, combining some like terms, you end up with negative 2 equals 3, okay? Which means that line 3 is not on the plane, all right? It's parallel to the plane. Line 3 is parallel because you end up with something that is not true, okay? So those are the only 3 possible things that can happen. So now let me show you another way, okay? So again, second page of your notes here. And I want you to notice, I believe it's the exact same plane, right? I think I gave you the exact same plane. In fact, it might be the exact same lines. I think it is. All right, so we're gonna do this one, again, in a different method. This one's not as efficient, I guess would be the best word, because it's only gonna tell you whether the lines are perpendicular to the normal. It's not gonna tell you an intersection point either. So let me just kind of explain. So for line 1, I know which direction this line is going because of these denominators. Line 1 is going in this particular direction. And if I multiply this by the normal vector, right, and I get the normal vector from the original plane, 2, 1, negative 1, right? If I do the dot product there, if it equals 0, then I know that this is perpendicular to this. So let's see, if I multiply, I get 4 minus 1 minus 3, which does equal 0. So I know that this is either, right? And it doesn't tell me the details. All I know is that this is either on the plane, right? It's either on the plane or it's parallel to the plane. That's all I know. I don't know, which of those two. It's just one or the other. Okay, for line 2, the direction vector is 1, 2, 5, right? And if I do the dot product of that with the normal, I get 2 plus 2 minus 5, which is negative 1, okay? So all that tells me is that since it's not perpendicular, it has to intersect. Right? Because I do not get a 0, it has to intersect. Now, do I know where? No, not at all. I just know that it intersects. All right? And then line 3 has a direction vector of negative 1, 4, and 2. And if I do the dot product with 2, 1, negative 1, I get negative 2 plus 4 minus 2, which does equal 0, which again, it tells me that it's either on the plane, right, or it's parallel to the plane, but not which one, right? It's not as detailed as the first one, but this is a heck of a lot easier than the first example. So at least maybe you could narrow it down and go, okay, hey, I know this intersects, now let me go do this the other way. All right, anyway, hopefully it's useful.